What's going on, Algebra?
What's going on, Bachelor?
What's going on, Algebra 2 Sphinxgalis? What's going on? Can you do it?
What's going on?
No, you gotta go, what's going on?
What's going on?
Alright. This is Griffin. This is my 3-year-old son. He's a funny... Audio check. Sorry about that. Okay. Shiloh, can you take Griffin out? Because I gotta teach my class today.
Griffin, every word of God is flawless.
Alright, so check this out. No, you gotta get out.
Shield to those who hate.
Okay, you guys go out. Good job, Shiloh.
In him. Griffin.
Okay. I need to teach my class, so everyone has to get out. Ben, you too. Alright. There. Can you guys hear? Can you see? Okay. Then let's get this party started. I'm going to do my best to cover Chapter 7, Poly 7, as best as I can today. After I cover Poly 7, let's see. On Wednesday, I covered Poly 6 and Poly 8. And Poly 8 is at the end. That's the end of it. So after I cover Poly 7, after I cover Poly 7 today, that should be pretty much the whole thing. What is your midterm exam going to be like? Okay, some of you, actually, most of you didn't like my past midterm. The one with the basketball. I don't know, some of you did, some of you didn't. This midterm is going to be more of a straight ahead test. It's like the traditional, I'm going to give you, I don't know how many problems, and I think some of them are going to be multiple choice, and some of them are going to be like just solve it, and it's going to be almost exactly like your homework. Okay? All right. Okay, Lucas, what Lucas is finding out is he's saying, hey, wait a second, some of these assignments are disabled. And give me a second, let me close my closet door. You guys don't need to be seeing my messy house. All right. Lucas is saying some of these assignments are disabled, and what I'm doing is I'm canceling out the 4 assignments that are worth the most points that you guys did the worst on. So whatever assignments you did the worst on, that is the most amount of points, I discount them from the grade book. A lot of times if you got a 0 on it, then that is the one that you did the worst on. So the one that has the most points and you did the worst on, I cancel it out of the grade book. That obviously helps you out greatly with your grade. Right? It brings your grade up a lot because I'm not counting this huge 0 that you got. So whichever assignments that you did the worst on, even if you did every single assignment, I'll still cancel 4 of them. I'll just choose the ones that are the ones you did the worst on. The computer automatically does it for you. So no matter what you do, Lucas, if you do every single one, I'm still going to cancel out 4 of them because I'm just choosing the 4 ones that you did the worst on. And if you only missed 1 point on some of them, that's going to be the one I cancel out. It still helps out your grade significantly. Okay. You need to get out.
I know.
Okay. The test, I'm not sure. Okay, he needs to get out and close the door. The test, I'm not sure how long it's going to be. Hey, out. I hope it doesn't take too long. I might give it as a bunch of series of small tests. I don't suspect the final one will be more than an hour, but I might give a whole bunch of smaller tests over the next week. Because, to be honest with you, I'm going to be done with all of my lecturing, hopefully by the end of today. And once I finish that, then we're good. Anyway, I got to get started because we're already 18 minutes into the class. I haven't even started yet. So, we're talking Poly 6 or Poly 7, and there's some new techniques that I have to teach you in this one, but it's not really that bad. Actually, to be honest with you, I don't think that anything I'm going to teach you today is anything new. It's basically just saying, hey, remember? Okay, I need you guys to go out. Remember what we did from before, and we're going to take bits and pieces of that stuff. Sophia, you're asking about domain and range, and that's funny that you asked that today, because today we are actually exactly covering domain and range again. But anyway, it's basically we're taking bits and pieces of old stuff and saying, hey, remember that technique? Let's pull that stuff in so we can bring it in and show you how to use this when we're applying this to polynomials. It's actually a really cool chapter. Let me pull it up and see if I can find it. All right, here we go. Okay, here we go. Let's close this. We'll minimize this. And we will move this over here. All right. Let me look at a problem. Okay, here we go. Today is going to really suck in terms of writing things down. I don't have my whiteboard or anything that I can use to write on a screen. So, okay, I know what I'll do. I know it. I'm going to teach you using Desmos. Yeah, today's really going to suck when it comes to that. So here's what I'm going to do. I'm going to stop my webcam. I'm going to share my desktop. Bradley, I will try to make sure that the exams come out before December 16th. Let me know when you guys can see my desktop. You got it? All right. Let me look at something real quick. I'm going to pull up in Desmos. We'll probably be switching back and forth. Okay. Here we go. All right, so check this out. What we want to do is we want to look at these two graphs. We want to look at these two graphs over here. And what we want to do is we want to say this graph right here is... Yeah, Bradley, you can take the exams early. All right, let me look at these two graphs right here. I'm going to hit Desmos real quick. All right, 2x cubed minus 3x squared. All right, 2x cubed minus 3x squared minus 2x plus 1, minus 2x plus 1. All right, and then the other one is x cubed plus 3x squared minus 13x plus 7. All right, cool. All right, so check this out. Say that what I wanted to do was I want to figure out when this graph in blue is bigger than the graph on the red. When is the graph in the blue is bigger than the graph on the red? Do you guys understand what I'm saying? And what I mean by bigger is it's pretty straightforward. Is basically above. When is this one above the graph on the red? When is the blue higher than the graph on the red? Do you guys get it? Okay, all right. Yes, exactly, Cameron, when you have a larger y. Very good. Now, if we could graph the things, it would be pretty straightforward. It would be extremely easy. If we could graph those things, then we would say, oh yeah, I can see it right there. It's in between negative infinity all the way up to, looks like 1, okay? Between negative infinity and 1, between x equals negative infinity to 1, so that would be one interval, and also between whatever this number is to infinity. If I were to write that in interval notation, it would look something like this. Between negative infinity and 1, union some number like 1.8 to infinity. Oh, oops. Sorry. Negative infinity to 1, or union 1.8 to infinity. All right, that's what I would do. Do you guys understand how that works? Do you guys see that? Well, I mean, do you kind of understand? I'll tell you what. The 1.8 is not exact. I just guessed the number based off of what the graph looks like. But what I'm saying is, do you see how the blue line is above the red line anytime you give me an x that is between negative infinity all the way up to about 1? Do you see it? The reason why it's 1 is because, look, at x equals 1, those graphs cross, or at least they touch exactly at the same spot. And then after 1, the blue line goes below the red line. Do you see how that works? So this x equals 1 is kind of an important thing. Oh, and why negative infinity? Because the blue line is above the red line anytime you're to the left of 1. So it's all of the numbers, you know, this way, all the way up till 1. And then my other time when the thing crosses is, it looks to me like at about 1.8. It's hard to see it, really. But it looks to me like they cross again. They almost meld into the same line. Actually, I might be mistaken. It could be 2.0. So, between those two numbers. But do you guys see how this inequality works? Now, how would I figure out? Okay, Sophia, you don't get the negative infinity part. This is kind of an important idea. Do you understand why it goes up to 1? Okay. And do you see how if I'm at an x value to the left of 1, then my blue line is going to be above the red line? any value to the left of the number 1. The blue line will be above the red line. Okay, all right. Now, another thing I would say is it almost looks, it's hard to see in this graph, but very faintly, maybe around here. Oh, okay. So the reason why I'm going from -1 all the way to, or from negative infinity all the way to only 1 is because after 1, the blue line goes below the red line. Right, the question that I'm asking is when is the blue line greater than the red line? When is the y value of the blue line bigger than the red line? And the answer is, well, between negative infinity and 1, and also it looks like around here, somewhere around here, maybe 2, between 2 and infinity. It's hard to see, but you can barely see the red line, the red faint line over here, and the blue line go above it. But then on this side, it's, and the reason why I say, 2 is because what's happening is Desmos is giving me this number 2. It's saying, hey, this is an important point. Just like it's saying this is an important point. It's at 1, -2. This is an important point at 2, 1. Do you guys see how this works? So I'm saying that at 2, and anytime I'm on the right side of that number 2, this blue line will be above the red line. Now, what if I didn't have the graph? What if I didn't have the graph to be able to do this? This, believe it or not, this problem is actually easy. What happens is, do you remember what happened when we had 2 lines and we wanted to see exactly where they crossed? Yeah, that's right, Sophia. What we did was we set them equal to each other. We said if they cross, then the y value here has to be the y value there. And if that's true, then I can just set this equation equal to this equation. Do you see that? I'm almost curious, and I haven't worked this one out, but I'm almost curious to know if I can do that right off the bat. Y equal and not greater than or less than. Well, because Sophia, what I'm trying to do here is I'm trying to figure out these important points. And by important points, I mean there's 2 points of real significance in this graph. It's where those things cross. It's where they are touching each other. Do you see? And if I could figure out where they are equal to each other, then by doing some random testing, I could see which one's above the other. Do you see what I mean? But knowing these 2 points right here, 1 and 2, those would be important to me. Now, I didn't work this one out, but I want to see if I can do this, and hopefully I can do this quick enough. Let's see. Not write LaTeX. How's about LaTeX equation editor? All right. I'm going to do my best to type your math out today. It might be slow. Hopefully it's not too slow. 2x cubed. Actually, wait. I wonder if I can copy and paste this. There we go. Can you guys see this right here? All right. So what I did was pretend I didn't have the graph. I didn't have this advantage of having this awesome graph. So what I end up doing is I say, all right, let's set it equal to each other. Now what I'm going to do is I'm going to take everything over to the left side. So I'm literally going to copy and paste it, but I'm going to put a negative in front of all of these. negative here, a negative here, a positive here, and a negative there equals 0. All right, do you understand how I went from the top line to the second line? It's very simple. All I did was I subtracted the x cubed to the other side. See, it's right there. I subtracted the 3x squared over to the other side. I added the 13x to the other side. I subtracted the 7. All I'm trying to do is simplify this thing a little bit. Okay? I'm gonna simplify like terms. So let's see if I can do this. Ignore that line real quick. Let me just fix it up real quick. This would be a 1. This would be a 6. This would be a 12. No, wait. This would be plus 11 x, and this would be minus 6. Is that correct? 2x cubed minus x cubed is 1x cubed. This is negative 6x squared. This is 13x, and this is negative 6. Okay, cool. All right. I'll be honest with you. I'm looking at this, and this might be a little bit advanced to factor right now. I don't want to go through long division. I'm just going to move on, but I wanted to kind of show you this to start off with this idea. This was our warm-up. Cool? All right. Now, this might be on the test, and I'll tell you what, I will spend more time on this on Wednesday. I'm not going to finish chapter 7 today. I'm just starting this idea. And then on Wednesday, when I have better equipment with me, I'll be able to cover more of this stuff. All right. So let's see. Let's see. What is it that I want to cover with you here? Oh, okay. So here's the graph of f of x. Can you see it? All right. How are we supposed to factor that equation though? Oh, okay. What might have to happen if we don't know how to factor that? I'm just letting you know, Sophia. I'm not going to demonstrate for you. I'll tell you what I'm thinking. What might have to happen is we know this number pretty accurately, the 1. It's hard for us to see this number, the second number. In fact, if you go back here, the graph that they gave says, okay, this number is at x equals 1. That's one of the factors. But at x equals, I don't know, that's another one of the factors. Do you see that? It's around 2. I can't say it's exactly 2, but I say it's around 2. Well, here's what I would do. Is I would go back to this thing and I would say, well, apparently x minus 1 is a factor. And then I would use the long... Do I even have a long division? I don't think I even have a long division symbol in here. And so I would take this thing right here and I would use long division on it. I'll be honest with you, it would be a pain in the butt. But, I mean, that's what you would do. And then from that, you can get the other factor of it and so on and so forth. But here, let me show you this thing, because this is actually... this stuff really is a lot easier than I think that I started it off as. I think I started this off in the wrong way. We have our graph f. Let me ask you, when is f of x bigger than 0? Look at the graph. When is f of x bigger than 0? There we go. Between negative infinity and negative 1. And also 1 to infinity. Exactly. Very good. If you wanted to write that in interval notation, it would look like this. Negative infinity to negative 1, union 1 to infinity. That's the way I would write it. Now, Sophia, what I'm going to ask you is, you were able to tell me that answer pretty quickly, but really the key important parts were, when I asked you this question, what you had to do was you had to answer this question, right? Because when I asked you, when is it greater than 0, you first had to answer, well, when is it equal to 0? And I think this relates back to your question where you were saying, hey, why are you setting this not to greater than or equal? You're setting this equal to 0, each other. Because that's what we want to find. We want to find these key points. Does that make sense? All right, let's look at this one. What about g? When is g bigger than 0? Sophia, here's what I would say. If you want to write it like that, I would say f of x is greater than 0 when x is smaller than negative 1, or x is greater than 1. That's what I would write. Now for g of x, personally, I like this type of answer. Let's see. I'll just have to retype it because it doesn't look like it's going to let me. Personally, I like this one. Something like that. Okay, and Cameron, yes, you answered my question about when is g bigger. Yes, absolutely, between negative infinity and 3, and also 1 through, or negative 1, all the way up to infinity. That's when g is bigger than 0. Are we cool? Okay, so let me show you guys how to use this stuff really quickly. Really cool. It's pretty awesome. All right, check this out. What are the intervals when this number is bigger than 0? When is this thing positive? If you want, we could multiply this all out and get an x cubed plus some kind of number x squared plus some number x plus some number. But here's my first question to you. Take a look at this problem. I'm going to ask you, when is it equal to 0? What are the numbers when it's equal to 0? All right, 2, negative 3, and where? And what else? And positive 3. Okay, here's what I want you guys to do. Here's what I want you to do. This is important. This is a key step. And I don't know how to draw this on the computer. So I want you guys to listen to my directions and draw it exactly. I want you to draw a number line. Just draw a horizontal line and put a 0 in the middle, and then go all the way up to 3, or go all the way up to 4, positive 4, and go all the way backwards to negative 4. Do you guys understand what I'm talking about? Do a straight ahead number line like we did back in kindergarten, and draw from negative 4 all the way up to positive 4. Okay? Do you guys got that? All right, now what I want you to do is put dots at positive 2, positive 3, and negative 3. Those are our points of interest. Those are our interesting things. You got it? So you have a number line that goes all the way from -4 all the way to +4, and you put solid dots at -3, 2, and 3. Okay, now here's what I want to do. I want to figure out, when is this thing positive? So if I plug in 2, -3, or 3, what will my answer be? If I plug it into here, if I plug it into this expression right here that I have highlighted, what will it be equal to? It will be equal to 0, and that's not helping me because that's not telling me when it's greater than 0. You guys see? So here's what I'm going to do, is I'm interested in the intervals in between those points of interest. I'm interested when in between those things. So give me a number, any number that is between -2, or I'm sorry, -3 and +2. I like Lucas's number the best. 0 is always easy to plug in. Okay, suppose we plug in 0 into here. Replace the 0 with an x. Tell me, is that answer positive or negative? Just 0. No. You plug 0 in for x, so you have 0 minus 2, which is -2, 0 plus 3, which is 3, and 0 minus 3. So is that going to be, what is -2 times 3 times -3 is, it's positive. Very good. Okay? So I would venture to say that all the numbers between those 2 points of interest, that would be all the numbers between -3 and +2, are all going to be positive. Let's try another area of interest. Okay, Sophia's asking, where did I get the -3 all the way to the 2? Where did I decide those values? Here, I'll tell you, it's really interesting. It's really easy. Well, because that's our points of interest. That's where it's equal to 0. Here, I have to go. I have to teach chemistry now. But let me show you this on Desmos real quick. X minus 2, x plus 3, x minus 3. All right, so check this out. -3, +2, and +3 were our points of interest. Those are our interesting points. And I don't want to say greatest extremes. That is a different value altogether. But -3, +2, and +3 were interesting to us. We discovered that if we plugged in 0, our answer would be a positive number. As you can see, it's positive 18. But look, all of the numbers in between -3 and +2 are all positive numbers. Do you see that? Without looking at this graph, I was able to tell you where this graph was positive. Yes, and between 2 and 3, they're negative. The y values are negative. That's what I'm saying. And when you're above 3, in fact, if you were to choose a test point, like let's choose a number that's bigger than 3, let's say 10. Okay? 10 minus 2 is 8. 10 plus 3 is 13, and 10 minus 3 is 7. If I have 8 times 13 times 7, it's going to be, I don't care what the number is, I just want to know is it positive or negative. It's a positive number. So I would venture to say that everything after my point of interest, which is 3, is going to be positive as well. It's because these points of interest are where the thing changes. It's where the sign changes from one to the other. So if I'm standing on one side of that, interesting point, then I would get a certain answer. And if I'm standing on in between these interesting points, I would get, this certain positive or negative values. And that's the key behind this chapter. I have to go. I should have started chemistry 2 minutes ago, and they're going to be upset at me if I don't. I apologize. I'm really excited about this, but, I'll cover more on this on Wednesday. All right. Okay, bye.